Integration is sorry, and then you subtract 1 from the power. Integration is the reverse. You first add 1 to the power and then you divide by the new power.
Okay.
And there's a little extra something we'll do later. Okay, how about this one?
So you add to the power first?
Yep.
So it'd be a fifth x to the power of 4. 5, sorry.
Yeah. B.
Minus a quarter.
Yeah.
X to the power of minus 4.
Hope that's it. Oh yes. Let me see. What is the derivative of a number?
What do you mean by that?
So let's say, what is the derivative of x squared minus 3?
Would minus 3 become minus 3x? If it was integration.
You're too clever. That's integration. Differentiation?
2x, just 2x.
Yes. And so when we're integrating, there could have been a number that was obliterated when we differentiated. And so at the end, you just write plus c.
Okay.
Because there could have been some constant that was there, but we can't possibly know what it was. This is what the exam questions look like.
Okay.
Let's just pick one. Let's just do the last one.
Okay. So do we expand the brackets?
Yep.
Okay. Would minus 3x times minus 3x be 6x squared? No, 9x squared.
Correct.
So would it be 9x squared minus 6x plus 1, and then we integrate from there?
Yep.
So for 6x, would it be 12x squared?
Divide.
Integrating.
Divide.
Oh, you divide, don't you? So it would just be 6x. No, wait, there'd be 3x squared.
Yep.
So the answer would be 3x cubed minus 3x squared plus 1x.
Yep.
Plus c.
Well done. Yeah, done me pretty good. Let's see. 3x squared minus 3x cubed minus 3x squared plus x. Let's see. Alright. How about this?
Okay. I got for 8, 9 over 2x to the power of 3 over 2.
Okay, and B?
Would that just be 3x plus c?
Well done. And in fact, I'll stick a plus C for the first one as well. Let me see. So for the first one, it's not 9 over 2. You multiplied it.
Oh yeah, I did. Oops. I keep multiplying it. It's divide, isn't it?
Mm-hmm.
So it's 3 divided by... which is 2.
That's it. Alright, how about this?
Okay. So would the answer be 3x squared minus 1x to the power of minus 2 minus 2x to the power of 3 over 2 plus c?
Let me see. What was the middle one?
Minus x to the power of minus 2.
Yeah. And then what was this one, sorry?
Minus 2 to the power of 3 over 2. And then plus c.
Plus C. Looks good to me. I thought you'd be fine. 3x squared minus x minus 2 minus 2x to the 3 over 2 plus C. Alright. I'm not doing it. You're going to be fine. I'm just going to imagine this squared thing wasn't here.
Yeah.
What if it was just the f dash of x equals 4 minus 2 root x? How would you get the f of x for that? Or how would you go about it?
So could you write out as 2x to the half?
Correct. You could write that as 4 minus 2x to the power of a half.
Yeah.
You'll be fine for the rest of that. Don't worry about that. Okay, this is more like it. This requires binomial expansion. Okay, do you remember how we could do this one? The coefficient of the x cubed term.
No.
3 brackets. That's how I remember it. For binomial expansion. So what are our 3 brackets? So if they want the x cubed term and the maximum, the power is 4. So that's 4 choose 3.
Oh yeah. And then would it be to the power of 4?
Let me see. No, we want the x cubed term. So the second bracket is p. And do you remember final bracket?
Is it 3 choose 4?
No, minus 5x. So we want the x cubed term. So the final bracket will be cubed. And so
one on the left would be cubed.
So this one will be power of 1.
Yeah.
So that they add up to 4. Okay. So calculator
Okay.
without the x. And I suppose without the p as well. And we'll have to just put them in.
So should I put p as 1?
Yeah. You can do x as 1 as well, or just leave it out. Just don't put it in at all.
I got minus 500.
So minus 500. Okay. And now put the stuff back in that we took out.
Put the stuff back in.
So you couldn't put in p or x?
I put p in as 1.
Okay. So we now have to put it back. So minus 500p.
So instead of p, just put minus 500.
No. So basically, okay, so 4 choose 3 times by p times by minus 5x cubed.
Yep.
In the calculator, you could put like 4 choose 3 times minus 5 cubed, and you'd get minus 500. And then times by p times by x cubed. Okay, we're told. Okay, how do we find the value of this one? So that's equal to minus 1000 x cubed. You know what? Let me put a line through this. It just does not belong in this section at all. Don't know what the book was thinking. Alright. No, I'm doing that. Okay, then you just solve. You just solve for p.
Okay.
And so any idea what p is?
Would you divide by minus 500 on both sides?
Yep.
Which is 2. So p is 2.
Great. P is 2. This is a terrible question. Let me just see this. So they want me to expand that. No, it's terrible. Terrible. Delete this whole thing. Want me to expand those brackets. It's crazy. So this looks better. But okay. I want to check if exam questions are similar. Just because. So it seems like it should be, but we'll see.
Yeah.
Let's see. These are fine.
Yeah.
Let's try questions C and D.
Okay. So do I do everything in the bracket first?
The bracket is just integrate what's in the bracket. It just looks like that.
So for the first part, would be a third p cubed.
P is just a number, I believe. So let's say, what would be the integral of the second part? P and Q are just numbers. Constants.
Minus x to the power of minus 1.
The Q part. What would be the
Wait, for which part?
The Q part. What would be the integral?
The Q part. That would be px.
QX?
Qx.
Yeah. So Q is just a number. P is also just a number. And so that's what you would do.
Okay. So it'd be a third px to the power of...
No, p is just a number. That's p won't be affected. So you just integrate q. So you just integrate x.
Okay, so that'd be minus x to the power of minus 1.
And so it would be minus p squared x to the minus 1.
Yeah.
P squared x to the minus 1. Because if it was like, if it was 9x to the minus 2, the integral would be minus 9x to the minus 1. If this was 9 is 3 squared, and so it's the same thing. So it's just in terms of like a letter representing a number.
Yeah.
And how about part D?
So it'd be 4 over 3t.
Well done.
And then cubed.
Yep.
Plus 6x.
Not x.
T.
Yeah, because it's now with respect to t. And plus c. Great. That's it. Okay. How would you start part A?
You turn minus 3 root x into 3 to the power of a half. 3x to the power of a half. And then the other one will become 2 over x cubed can become 2x to the minus, is it 2/3?
Just to the minus 3.
The minus 3, okay.
The power is connected only to the x.
Oh, yeah.
Then you're fine for that. Okay, how would you start B?
Multiply x by everything in the brackets.
What would you get?
X cubed plus 2x. Wait, because first would you change the 2 over x to 2 to the minus 1?
You could, but x times...
Or would it just be 2 over x squared?
X is the same as x over 1. X divided by 1 gives you x.
So it'd be 2x over x.
Yeah. Simplify.
X cubed plus 2.
Correct. And C.
So would you get, for the brackets of 2x, would you get 4x squared?
Yeah.
Plus okay. Minus a half x. Wait, would that be right? X to the power of a half, because like the x on the top of the fraction would give you x to the half.
Yeah.
And then if you would you need to flip the fraction so at the bottom x becomes minus?
So I would do it as x to the minus 2. Instead of divided by x squared, do it times x to the minus 2.
Okay. So it'd be times x to the half plus 5.
Well done. And so what do you get when you expand that part?
Okay. You get 1 for x, so just x.
Shouldn't. No calculator. X to the minus 2 times x to the half. Or you can use calculator, but just
minus a quarter.
You add them. And so it's minus 2 plus a half.
So it'd just be 2.5.
Calculator.
Oh no, 1.5. It'll be 3/2.
Calculator.
Okay. Minus 3/2.
Yep. And so x to the minus 3/2. And the other one?
5x to the minus 2.
That's it. And then you integrate from there, but that's the integration bit is the easy bit for this.
Yeah.
This is pretty strange. All right. Let me just see something first. All right, better do it. Hang on. No, not just yet. Why would they put me through all that if it wasn't important? Example 5. I want an x over an x. 1 second. So this is pure 1 integration. Pure. Okay. Come on, book. Yeah, I like the look of 3C.
Okay. Okay. So would it be? I got 5x to the minus 2 for the first part.
Mm-hmm.
Minus 7x.
Mm-hmm.
Plus 4x to the minus 7/2. But I think that's wrong.
That's right.
That's right.
And then don't forget, believe it or not, at the end we have to integrate the whole thing. It's just that that's the easy part.
Yeah.
Compared to that. Okay, I'm happy. Okay, what on earth is this about? We have to integrate this thing.
Do we want to get rid of the power of a half on y first?
Correct.
So can we square root both sides?
So the power of a half is square root, isn't it?
Oh, right. No, it isn't.
Yes, it is.
So you can square it
Say it again.
So can you square root it?
To the power of a half is square root.
Oh, so can you put it into... Oh, right, okay, so can you put it into square root? Oh no, could you square it? So put it into square root, then square it, which cancels them both out.
Correct. So we square both sides.
Yeah. So on the left side it'll be y equals, and then 12x, then a fifth, 2 over 5, up to the power of 2 over 5.
Yep.
Minus 5 to the power of 2. Was it 3? Because you add 1.
You've lost me. Hang on. So it helps to write it out twice.
Oh.
So it's not 12, it's 36.
Okay.
Yeah, it's a mixture of multiplying and adding.
So would it become 36x 2 over 5 minus 60x to the power of a fifth? Or would it be 2/5?
A fifth. Multiplying changes the power.
Yeah, plus 25.
That's it. Okay. And now let's integrate it.
Okay. So for the first part, would you get 50.4x over to the power of 7 over 5? Because you add 1 to 7.
Yeah. X is 705. And what was this one? 50?
50.4. Oh no, you divide, don't you? Wait, did I? Wait, I multiplied. Okay, 36. 25.7 to 1 decimal place.
What would it be as a fraction?
It would be 180 over 7.
Yeah. Okay, go on.
Okay. The second part would be minus 50x to the power of 6 over 5. Plus 25x plus c.
Looks good to me. Great. Yeah, it was y to the power of a half, which is square root, and so square both sides.
Yeah.
Okay, integrate this.
Okay. I got 14x to the power of a half.
Okay. Let's try this one.
Okay.
What was the working out for this one?
So I changed the x into the square root x into x to the power of a half.
Minus a half.
Yeah, when you flip it. So it's minus a half, and then you, yeah.
That's great. Okay, and this one. Hang on, this one looks fine to me. Am I crazy? Yeah, it looks fine.
Yeah.
This one.
Okay. So I got 2x to the power of 4 plus 3x squared minus 6x to the power of a half.
Plus c.
Plus c, yeah.
2x to the 4 plus 3x squared. So 6x to the half is the same as square root. Yep.
Yep.
Good. Let me see this one. It's fine. Fine. Okay, remember this.
Okay. So does that become 11x to the power of minus 3 over 2?
What would be 11 over root x?
11x to the power of minus a half.
Yeah. And so 11 over cube root x?
Would it be 2 over 3?
It would be a third. Minus a third.
That's it. Okay.
So let me know when you have this one. The audio went a bit weird.
Oh, okay. I've got 33 over 2x to the power of 2 over 3.
So the 2 over 3 was it?
Yeah, 2 over 3.
Okay. Sorry, the audio cut out. I didn't know if you said it. Okay, let's try this one.
Okay. Okay. At the end of the question, 2 over x squared, what does the comma mean? Is the comma supposed to be there?
Comma is just
Right, to separate the
in terms of
sentence.
English. Yeah.
Okay.
Yeah, it looks like it's in the power instead of.
Yeah. So I got 3x cubed so far. 3x cubed
Okay.
minus 7x to the power of a half
Mm-hmm.
plus 4x to the power of minus a third
Yep.
minus 2x to the power of minus 2.
Yep.
And then can you simplify
Nope.
them? You just integrate after that.
Yeah, different powers.
Okay.
If you could simplify them, then you could have simplified them up here.
Yeah. So that'd just be a quarter, no, a third, no, 3/4, 3/4 x to the power of 4
Mm-hmm.
minus 14/3x. 14/3, yeah, to the power of 3/2 plus 6x to the power of 2/3 minus 2x and then plus c.
I think is it plus 2x
Is it?
to the minus 1?
Oh yeah, and then you multiply, which gives you positive. And then plus c, yeah.
Let me see this. 3/4 x to the 4 minus 14/3 x to the 3/2 plus 6x to the 2/3 plus 2x to the minus 1 plus c. Yeah, so that one minus minus. Let me see this one. Find the values of a and b. Let me see something here. All right. Yeah.
Are we able to work out the stuff in the bracket or not yet?
Nope. It's just in a bracket saying they're both integrated.
So we can integrate 2x cubed minus 2/x to the 4 plus c.
Say it again, sorry.
Can we integrate 2x cubed minus 2/x to the power of 4 plus c?
The integral of the left side gives you the right side. And so you have to say what are the what is A, what is B from that.
Okay. So can you make them equal to each other, then cancel stuff out?
Okay, once you integrate it, you can make them equal to each other.
Which one to integrate?
The one with the big integral sign with the D.
Oh.
Yeah, man. So maybe, 1 second. After this lesson, I'll improve this a bit. This reminds me of all the way back here. This one here, part C, where P is just a number, Q is just a number.
Okay.
And you're just integrating with respect to X.
Okay. So it'd be a b a third x to the power of 3.
Yeah, we usually write it as a third AB.
Okay. Which would then become, so it'd be a third ab minus, no, a third abx to the 3 minus bx to the 4 minus 4.
Okay. And so
Integrate.
you just did integrate, didn't you?
Oh, we just did integrate.
So we're trying to figure out what is A, what is B.
Can we make them equal to each other now?
Yeah. And actually, something I don't like about this, they should have used the identity symbol. They're identical to each other.
Yeah.
I suppose there should be a plus C as well.
Yeah. It'd be, could you change that into x minus 2x to the minus 4? You could change minus 2 over x to the 4 to minus 2x to the minus 4.
Correct, yeah.
Would that make it easy?
Yep.
So the c's cancel out.
Yep.
And we now know that b is minus 2x.
Minus 2.
Minus 2.
Actually, this says minus B, this says minus 2, so B is just 2.
Okay, yeah. So now that b equals 2. So can we put b into the equation on the left to work out a?
Yep.
So it'll be a third a 2a.
Times 2, yeah.
And then x to the 3.
Mm-hmm.
And then could you multiply 2 and a third together?
Yep.
Okay. Which is 2 over 3.
Mm-hmm.
2 over 3a x to the 3. Okay, so 1. How come you wrote it like that? You put like the identity sign between them.
Like these two are identical to each other, but then this will be equal to something else.
Okay.
So what is this equal to?
That equals to 2x cubed.
Yeah.
And then could you divide by 2 on both sides?
Yep.
Which gives you a third ax to the 3 equals x cubed.
Mm-hmm.
And then you could cube root both sides.
You could divide both sides by x to the 3.
So a third a equals, well, what would it equal?
What's x cubed divided by x cubed? What's 2 divided by 2?
1. So it equals to 1. Well, a third of a is equal to 1, so you times by a third on both sides. Oh,
Yeah.
wait, divide by a third or times by a third?
Divide.
Okay.
Same as...
Which give you 3, yeah.
Mm-hmm.
So a is equal to 3.
A is 3, B is 2.
Yep.
Looks good to me. A is 3, B is 2. Great. Mm-hmm. Yep. Any question about that one?
No.
So this one's very similar. Is it worth doing? Or you think you're alright?
I think it should be fine.
I like that. Let me see this one. This is more binomial expansion, which I don't like. Given that x is small, so that... Find the approximation for this. Find the approximation. No. Silly. Okay. That stuff.
Or will be between a tick and a half.
I just want to check exam questions for this thing. Make sure. You never know.
Yeah.
See, it just makes more sense, like, to do that in binomial expansion, which we've done, and then you just integrate it at the end. Like, it's not difficult to integrate, you know, a number plus something x squared. The difficult bit is the actually doing it. Okay, let's try this one. This is the f dash of x. What is the f of x?
Okay. Well, you need to do integration to work out the f of x, right?
Mm-hmm.
Okay. I got 3x cubed plus 2x squared minus 3x plus c.
Okay, and that is indefinite integration. We now have definite integration. We're told that this point, that this curve y equals the f of x passes through the point minus 1, 0. How can we use that to find c?
Can we sub in minus 1 for x?
Yep.
So it'd be 2 cubed plus 1
Hold on.
squared.
No, don't. Never say that to me. It's not 3 minus 1. It's...
Oh yeah, it's 1... Wait, is it 1 cubed first? Oh yeah, you put it in brackets. Then you can put it into the calculator hole.
Yeah, and in fact, what makes it a bit easier is if you just put in minus 1, press equals, and then you can just do 3 answer cubed and so on.
Yeah. I got 2.
So that's 2. Okay. And so 2 plus c when x is minus 1.
Wait, so when x is minus 1. Oh, so it's asking us, so it's minus 3 then?
You know how we found the f of x?
Yes.
Y equals the f of x. And so this is
Well, y is 0.
yeah, and y is 0.
So you'd add -2. So, yeah, so c would be -2.
Yeah. And so what is now the full function of x? Now that we know what c is.
3x cubed plus 2x squared minus 3x minus 2.
That's it. So before we weren't able to know what number it was because it was obliterated when it's differentiated.
Yeah.
But now that we have a point that the curve passes through, then we can actually retrieve that the constant.
Yeah.
And if we go back, we can see here. So this one went through -1, 0. You've got 3 different curves here. This one goes through 0, 8. This one 0, 2. This one 0, -2. And so if it's plus c, then we just don't know which one it is. But if we know specifically a point, we can use it. Let me see. Yep. Okay, let's try this one.
Okay. So do we need to integrate dy dx?
Yep.
Okay. So that become c plus 10x minus x to the squared minus 3x squared minus 4/3x cubed.
And put c at the end. Okay.
Yep. And then do you put in 3 for x?
Okay. And you show you're working out by replacing the x with a 3 in a bracket. That shows you're working out. So that's the method mark. So you're basically just showing what you type into the calculator, essentially.
Yeah. I got -33.
Okay.
-33 plus c equals -15. And then you can plus 33 on both sides. So c equals 18.
And so find y in terms of x.
So do we write out 10x minus 3x squared minus 4/3x cubed plus 18?
Looks good to me. 10x minus 3x squared minus 4/3x cubed plus 18. Great. Any question about that?
No.
Nailed it. Let's see this one. The curve passes through this point, so they get a bit more complicated, but it's the same idea. We've done the complicated ones. They get a bit more complicated, but then you just sub in the 2 and solve.
Yeah.
That looks good to me. I'll go through all these to make sure. No, I won't. Got it. So finding functions.
Probably a tick.
And so we've got 3 sections done. Great. So it's always the same where the last section in a chapter is like quite difficult, but then the earlier ones we get through much more. Yeah, how was that for you, Adam?
That was great.
Great. Glad to hear that. Continue this next time.
Yes.
Any questions in general?
No.
All right. Well done, Adam. You did great.
Thank you.
And have a good weekend.
You too.
All
Bye.
right, take care. Goodbye.